Welcome to The Explainer. Let's treat our time together today kind of like a diagnostic clinic. We are diagnosing exactly how Cambridge AS and A-level mathematics students can completely, totally master Section 4.1 on forces and equilibrium. And we're going to focus specifically on resolving forces and calculating resultants. Look, if you've ever felt like you completely know the material, but the marks just aren't showing up on your paper, well, you are absolutely in the right place. I want you to consider something for a second. Why is it that students who clearly know the underlying math, the ones who have memorized all the formulas, still lose the easiest marks when resolving forces and calculating resultants? Honestly, it's one of the most frustrating things an exam candidate can experience. You put in the hours, you know for a fact that equilibrium means the net force equals 0, but then the final score doesn't reflect your effort at all. Well, today, we are going to fix that. So here's our game plan for today. We'll be hitting 1, mastering forces in equilibrium, 2, the 5-step processing system, 3, the top 3 examiner warnings, and 4, securing crucial method marks. All right, jumping into Section 1, mastering forces and equilibrium. Let's make sure we understand the core academic benchmarks. We really need to look at a critical distinction here, and that is superficial breadth versus analytical depth. See, a failing answer, or even just an average one, often overloads the page with superficial breadth. It's like throwing every single sine and cosine equation at the paper and just hoping something magically sticks. But the Cambridge assessment framework doesn't want that. It actively prioritizes and rewards true analytical depth. Examiners want to see logical, structured reasoning. They want to see that you actually understand why a normal contact force acts perpendicularly, not just that you know how to punch numbers into a calculator. And hitting that analytical depth means you have to engage 3 distinct cognitive domains simultaneously. First up is knowledge and understanding, which just means knowing your fundamental principles inside out. Second is application, actually putting that knowledge to work on the page. And third is analysis. A complete, really high-scoring answer meshes all 3 of these gears together perfectly when you're resolving a horizontal or vertical component. So the absolutely crucial takeaway here is this. Top-performing students exhibit a connected, conceptual understanding that is fully transferable to completely unfamiliar contexts. Let's be real, exam questions are specifically designed to look strange, to throw you off. Real mastery means you can resolve those forces, whether the object is sitting on a simple flat plane, or if it's suspended by 3 different strings at completely odd angles. You have to be able to apply those fundamental principles no matter how weird the scenario looks on exam day. Moving right along to Section 2, the 5-step processing system, we're going to build your procedural framework. Okay, this right here is the standardized sequence you really need to internalize. Step 1, identify the key elements. You have to deconstruct the question before you do literally anything else. Step 2, apply the relevant principles and pick your analytical framework. Step 3, execute your analysis with crystal clear working. Step 4, verify. Ask yourself, does a negative resultant force actually make physical sense in this specific context? And finally, Step 5, present your answer using the correct terminology. Following this exact system is a total game changer for eliminating those careless errors that bleed your marks. Just zooming in on Step 1 for a moment. Honestly, often the math isn't even the hardest part. Extracting the right data is. You've got to be able to pull precise values, like mass, tension, or friction coefficients, out of dense blocks of text and tables. You have to interpret the physical relationships between the forces they're describing and draw evidence-based conclusions before you even think about touching your calculator. Deconstruct the scenario first, select the right framework, and only then start calculating. Let's move to Section 3, Top 3 Examiner Warnings. Time to diagnose some specific symptoms. These come straight from the principal examiner reports, so listen closely. These are the exact pitfalls causing lost marks across the board. Number 1, forgetting proper format. That just hemorrhages easy marks. Number 2, poor presentation and failing to check your formatting. Look, if the examiner cannot follow your logic, they simply can't award you points. It's that simple. And number 3, generic, out-of-context answers. Cambridge wants to see you apply equilibrium principles to their specific scenario, not just regurgitate some generic one you memorized from a textbook. To dodge those warnings and actually hit those higher-order assessment objectives, your answers have to evolve. If we look at a basic descriptive approach, it really only identifies limitations and assumptions. An analytical approach steps it up a notch by comparing alternative methods. But that highest tier, the evaluative level, That involves making solid, justified recommendations based on the quality of the evidence. When you are resolving forces, communicating your awareness of assumptions, like treating a massive physical object as just a simple particle, literally elevates the quality of your entire response. Finally, we reach Section 4, securing crucial method marks. This is the definitive cure. I want you to burn this quote into your memory, straight from a senior examiner. Quote, "Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you." Guys, this is the golden rule of Cambridge mathematics. The process and your clear notation matter so much more than just rushing to a final number. Think about it. If you make a tiny arithmetic error on line 2, but your method for resolving the equilibrium is flawless, you can still salvage the vast majority of the marks. But there's a catch. That only happens if your working is clearly presented on the page. So how do we make sure we lock all of this in? Well, here is a really practical memory hack for you. Take the key terms we've been discussing for Section 4.1, things like identify, apply, execute, verify, present, along with core concepts like resultant and equilibrium, and build your very own mnemonic using the first letters. I challenge you to write one down right after this explainer finishes. It's an active recall technique, and I promise you, it ensures you won't freeze up when you turn the page and see a wildly complex forces question. I want to leave you with one final kind of provocative self-evaluation to think about. The next time you sit down to practice those past papers, really ask yourself, are you truly showing your analytical working step by step, or are you just rushing to get a superficial final answer? Start applying the diagnostics we've covered today. Show your methodology, present your answers super clearly, and let's stop leaving those easy marks on the table. Thanks so much for hanging out with me in this explainer. Now go out there and master those forces.